Matrices in word problems. In this video, I'm going to do a couple word problems wherein we set up some augmented matrices to solve. I'm not going to solve these matrices by hand. In fact, I'm just going to go to a matrix calculator to solve these. If you don't have one, I recommend using Desmos Matrix Calculator. Easy to use, very powerful. So the goal here is really just to set up a system of equations, get the augmented matrix, and then use a calculator to solve the rest of the way. So in the first problem, a florist is making bouquets for a wedding. She has $125 to spend on each bouquet and wants to use 24 flowers for each of the bouquets. Roses cost $6 each, tulips cost $4 each, and lilies cost $3 each. She wants twice as many roses as the other two types of flowers combined. How many of each type of flower is in a bouquet? Well, we have three unknowns really. We have roses, tulips, and lilies. And since we have three unknowns, we should have three equations. So let's see if we can make three equations. The first one I'm going to use with this information right there. There are 24 flowers total. So I can say R plus T plus L equals 24. R for roses, T for tulips, L for lilies. I'm also going to use some money information to get another equation. I know that $6 times the rose plus $4 times a tulip plus $3 times a lily equals the total amount of money, $125. Great, so we have two of the equations. There's one more piece of information given that we can use to get the third equation. And I'm going to start by writing it on the side. And the third piece of equation comes from this sentence. The florist wants twice as many roses as the other two types of flowers combined. So I know that roses is twice as many as the other two combined. Now, why did I put this on the side? When we're setting up systems and the augmented matrix that corresponds, we need everything to stay in the same order. So if I start with roses, tulips, lilies, number, I have to have roses, tulips, lilies, number, each of my rows. So I'm going to rewrite this one again over here on the right. So I have R is 2T plus 2L. And remember that I want RTL number. So I can do R minus 2T minus 2L equals 0. And that's going to become my third row. Once I have my system, I can easily type this into a matrix calculator after I get my augmented matrix, which is 1, 1, 1, 24, and then 6, 4, 3, 125, and then 1, negative 2, negative 2, 0. So in a matrix calculator, I would call it something here. I'm going to call A in my calculator. A equals that matrix. And then there's usually some sort of button that says RREF, which is row reduced echelon form if you want to know. And then do RREF of A. And when I hit enter, I get the matrix 10016. 0105 and then 0013. Remember that I have roses first, so I have R equals 16. I have tulips in the second column, so tulips equals 5. And my third column is lilies, so I have lilies equals 3. Let's take a look at one more example. This one might be a little bit tricky, but we'll talk through it. So the prices of three tables A, B, and C are X dollars, Y dollars, and Z dollars respectively. Person P buys 4 units of B, sells 2 of A, and sells 5 of C. Person Q buys 2 of C, sells 3 of A, and sells 1 of B. Person R buys 1 of A, sells 3 of B, and sells 1 of C. P, Q, and R earn $15,000, $1,000, and $4,000 respectively. What is the price of each table? Okay, once again, we have three unknowns, which are going to be X, Y, and Z. I know there's a lot of letters going on, A, B, and C, and P, Q, and R. But the variables we're going to solve for are X, Y, and Z, because we're trying to find the price of each table. I have three unknowns. I'm going to need three equations. And I have three pieces of information. So let's set up a system of equations. In fact, let's go right to the augmented matrix. Let's do that, because I think we can handle that. So I'm going to put A in my first column, or really X's, and then Y's, and then Z's, and then equals number, like this. Okay. So how would I do this? Well, it says I buy 4 units of B, but I want my A's, which correspond to the X's, right? So A goes with X, B goes with Y, and then C goes with Z. So let's get our X's first, which corresponds with the A. So I could say 2 with the X, and then how many Y's? Well, my claim is that it's going to be negative 4 of the Y, and then 5 of the Z. This is my person Q, and that person will earn $15,000. So here's the tricky part, if you would. Why are my X and Z positive, but my Y negative? Well, think in the context of the problem. If a person is earning money, they earn money when they sell something, and they lose money when they buy something. Do you see now why the A and C will be positive? That is, the X and Z will be positive, but the B or the Y will be negative. If so, see if you can write the next two equations. The second row corresponding to person Q. So my claim would be I would have 3A, or 3X's, 1B, or 1Y, but I'm selling, there it is, I'm buying 2 of the C, so I'm losing money when I do that. And that person would earn a total of $1,000. How about person R? They're buying 1 of A, that is 1 of X, so they're losing money, but they're gaining money when they sell the B and when they sell the C. And in total, they end up with $4,000. So this is my augmented matrix. Once again, I'm not going to solve by hand. I'm going to call this matrix B. I'm going to type that into a matrix calculator, and then I'm going to do RREF, row reduced echelon form of matrix B, and I get the following row reduced matrix: 1 0 0 2000, 0 1 0 1000, and then 0 0 1 3000. So what is the price of table A? Well, A is $2,000, right? A and X correspond. B is $1,000, and then C is $3,000.